Do you know how a tank capable of holding 50,000 liters of oil is manufactured? The precision involved in the production process of such a gigantic tank is beyond your imagination. Today, let's step into what is claimed to be the oldest mechanical factory in Korean history and witness the entire production process of these giant tanks. Having such a spacious factory in land-scarce Korea is truly rare. The first step in making these giant tanks is cutting the sealing rings at both ends of the tank body. Workers use a CNC pneumatic cutting machine to cut the steel plate precisely at the starting point. The marvelous electric welding arc marks a perfect circle on the steel plate, which will be the size needed for the top of the tank, with a diameter of nearly 3.2 meters. Once the top cover is cut, it is lifted by a magnetic crane and transported to the flanging machine. The whole circular steel plate is fixed through circular holes and begins to rotate. The rolling parts at both ends of the flanging machine gradually press the edges of the circular steel plate, slowly folding the curvature into a shape suitable for welding. This completes the end cover plates of the tank. Next, look at the materials needed to make the tank body. The material used is a low-carbon steel plate with a certain toughness for shaping and compression resistance. The steel plate enters a machine called a three-roll bending machine for shaping. As the machine operates with 3 rotating shafts, it is aptly named. With the help of an L-shaped angle iron, the entire steel plate forms the shape of a cylinder when the edges are joined together. Workers first use spot welding to fix the steel plate and grind the welding points temporarily. Then, they bring out the secret weapon, the automatic welding machine, which can move and weld autonomously along the laid track. It can be set with parameters such as speed and welding angle. The welding effect is more robust and aesthetically pleasing than manual welding. After welding, workers only need to grind off the oxidized welding material. This completes a section of the tank body. Workers use a crane to place 3 identical sections of the tank body on an automatic rolling machine. The base of this machine can rotate at a uniform speed, facilitating welding, drilling, and other work on the entire tank body. Workers carefully inspect the seams of the 3 sections of the tank body and then use an embedded welding machine. This machine sprinkles stone granules from a nozzle during the welding process. The stone granules control the temperature of the weld points and prevent sparks from splashing. While the welding machine remains stationary, the entire tank body rotates under the movement of the bottom rotary shaft, allowing for relative movement during welding. Once the tank body welding is completed, the end cover plates of the tank need to be hoisted and welded. Workers lift one side of the cover plate and align it, then manually spot weld it. Next, they use a particular automatic welding machine for circular cover plates, fixing the remaining welding work at the center of the cover plate. Then, an oxygen cutting machine is used to cut holes in the tank body. These holes will be used to install tank pressure sensors. The larger holes are called manholes, used for maintenance and cleaning during the tank's use. After cutting, the edges need to be polished with an angle grinder, and these accessory materials are installed into the openings. Using a level to ensure flatness and inspecting the gaps, once the data is confirmed to be accurate, the openings are sealed using welding, completing the process. After installing the maintenance and instrument openings, the entire tank body's external seams must be welded using an embedded welding machine. This dual welding process, both internal and external, ensures the strength of the tank body. After welding, non-destructive testing is required. First, white paint is sprayed on all the welded seams of the tank body. Then, liquid magnetic powder is used along with a fluorescent lamp to inspect each weld seam for defects. Once the inspection is completed, glass fiber cloth is used along with epoxy resin to wrap all the maintenance and instrument openings. Then, a glass fiber and resin mixture is sprayed onto the entire tank body. This is referred to as ERP patented technology. 3 coats of spraying are required for strength, and during each coating process, workers need to use a roller brush to ensure the glass fiber is smooth. This work carries a high degree of danger because glass fiber can cause severe lung diseases, so every worker is fully protected and vigilant. After spraying, workers bring out a high-temperature drying machine. Continuous hot air is used to dry the paint and epoxy resin quickly. During drying, accessories such as pressure gauges are installed on the tank door. Once drying is complete, the manufacturing process is finished. The completed tanks undergo a wall thickness test outdoors. After random sampling, it was confirmed that there were no issues and that these giant tanks were ready to be shipped for sale.